the origin A and B, and they're our fixed points, okay? And P is our moving point. It's going around such that AP bisects, I should put it over here, sorry. AP bisects this angle here. I'm calling it BPO. Okay? So that's why I've got theta here and theta there. Because if you're bisecting an angle, obviously both of the angles you end up with are equal to each other. Okay? Now, how do you go about solving it? Because it's got angles, right? It's something to do with angles. You can think of it purely in terms of gradient and use like tan inverse and that kind of thing. I went down that track and it started going really badly. So what I did instead was, I noticed that because we know where these points are, I know what this length is, namely it's 1, okay? And I also know what this length is, which is 2, right? So seeing as theta and theta in these triangles, I can use the cosine rule. Okay, I can find out what these angles are equal to exactly in terms of what the other three sides of the triangles are equal to, right? So if you remember, the way that the cosine rule works, if you're trying to find an angle, is cos of an angle is equal to a squared plus b squared minus c squared. And you can tell what the minus is because that's the one that's opposite the angle you're looking at, c and c. So this c in this case, for instance, if I was looking at this left-hand triangle, it would be the 1. That's the angle, sorry, that's the side that's opposite it, okay? All over to AB, okay? Now, I'm going to use this to find out what OP and AP and BP are, okay? Sorry, I'm going to use them to relate all of those sides to the angles, which is what I'm after, okay? Now, just to spare your sanity, I'm not going to put down all the lines of working that I've got here because they do get quite involved, but hopefully I'll put down enough so you can see what's going on. Okay. Right, so I use the cosine rule twice. I use it for APO and I use it for APB. Okay, so I get two expressions and eventually, after some simplifying, they look like this. APO is equal to, I think it's x squared? Yeah. X squared. Y squared. Okay, so there's the first one. Now, if you have a look at it, let me see if I can explain what's going on. There's a squared, there's b squared, and there's c squared. Okay, because it's just 1 squared, that's why it ends up as 1. And what are these two? This is the two AB. Why are they gross square roots? Can someone tell me? Why do they look so awful? It's just the distance formula, right? Thankfully, it's from the origin. It would be worse if it wasn't. From the origin to xy, that's what this length is, right? And this is for the next point along, okay? All right, now that's fine. Now, when you're doing the other angle, which is APB, okay, it follows much the same structure, except instead of going from 0, 0, I'm interested in this point along the end, okay? So it's going to be a little different, looks like so. X minus 1, is that right? Yep. X minus 3 minus 4. Okay, now, if you think this looks bad, just hold your breath. Okay, now, this is what we had. I think this is as far as we got last time. Is that right, Evan? This looks familiar. Like, we had this,
yeah,
and we just threw up our hands. We were like, what am I supposed to do with that, okay? Which is not a bad, like, I mean, that's a pretty ordinary thing to say when you look at that. However, we noticed that on the denominator, okay, we're going to have a few things in common. Namely, this 2 and this x minus 1 squared plus y squared, it appears in both, okay? So I'm going to get some simplifying going. The question is how much, right? So being that APO and APB, they should be the same. So cosine of APO and APB should be the same, right? So this is the line that I get, I think, after doing some cancelling. I'm going to get this. Okay, hold on, next page. Minus x on... Oops, sorry. Okay, so how did I get to this line? Here's what I did. Up here and here, you can simplify them a little bit. Okay, when you simplify this top cosine, you'll get this. Okay, and when you simplify this bottom one, you get this right hand side. Okay, now what would you do at this point if you had these two things equal? Okay, in some senses, this is the equation of the locus. It's just very messy. But what would you do to simplify it? Yeah, you're eventually going to have to, in either order, it actually doesn't matter which one you do. Number one, you're going to have to square to get rid of the square root signs. And number two, you're going to have to cross multiply because you've got these fractions and they can't really talk to each other because they're on different denominators. Okay? So I'm going to square everything and then I'm going to cross multiply both in the same line. Okay? So just brace yourself, alright? I had to use a computer to double check and make sure that I got this right, but you'll see why in a second. Alright, here we go. Take a deep breath. X to the 4y squared. Now, by the way, as I'm writing this is one of the reasons why I would suggest that you would never get a question like this in an actual exam. And if you remember anything about me telling you what makes a good question and what makes a bad question, right? What makes this a bad question? You tell me while I'm still writing this. You tell me.
It takes forever.
It takes forever. Well, that's true.
It's not hard forever, it's just forever.
Good, right. So this question is very long. It's very time consuming, but it's time consuming for the wrong reason. It's time consuming because number one, algebra. Number two, by the way, like this is actually the simplified result. If you actually wrote this down and broke out the factorization and expanded, it would take you longer because your line would take longer than this. So number one, it takes a long time. Number two, it just takes a long time to write. Like how long did anyone time it? Anyway, so there you go. What have I done?
Time on the video.
Yeah, that's true. Thank you. Okay, I've squared both sides. Okay, to get rid of the square root, and then I cross multiply. Now here's the thing. At first I thought this is just going to go badly, right? Like what gain is there going to be? Is it ever going to simplify? And I thought to myself, after I got over the initial shock of looking at this thing, I think it is going to simplify. Here's why, right? After I square everything out, right? Think about what you know about polynomials and their degree, right? For instance, this top line here, the left-hand side, when you square x squared plus y squared minus x squared, y squared minus x, okay? It's degree 2, right? For both x and y. So what was degree b after I square it? It should be 4, right? It goes from 2 up to 4, right? And if it was 3, it'd go 3 up to 6. Now, this is all going to be 4s. After I square it, this is all going to be 2s, okay? This will also be 4s, and this will also be 2s. So when you cross multiply, you actually see it here, right? Both sides will be in terms of 2 by 4 is 6, okay? And you can actually see it. I need another color, right? Can you see that? I've got one lot of y squared here, and I'm going to get one lot of y to the 4 up here, and I'll get exactly the same thing over here, right, when you cross multiply. So I'll just have one lot of y to the 6, and that's not the only term that's going to cancel. Okay, watch. Let's do it. Y to the 6 cancels. 3x squared y4 cancels. Minus 8x, okay, cancel. Now, this is interesting. They don't all cancel. They don't all come out in the wash, and that's because the coefficients you've got here are slightly different. Okay, so just be careful. 3x, that one cancels. 16 cancels. Watch for the coefficients. This one also doesn't cancel. 28 here. 31 here. Minus 18, minus 24 also doesn't cancel. But then, let's see, what have I got left? 9y squared. There are, did I write this down? I don't think, yeah, there are no 9y squareds over here. But then, it starts to collapse very quickly. X to the 6, 8x to the 5, 22, 24, and 9. Is that right? 9 wide of the 4. I think that's it. Let me just double check. Yeah, that's right. Okay. So, after we get rid of all of the disaster, the mess, okay, you end up with, I'm going to do 2 lines in one, okay? Number 1, I'm going to get rid of all of the things I've cancelled. And number 2, I'm also going to collect like terms. Because you can see I've got 6 wide of the 4 here. And I've got 9 wide of the 4 here. Right? So what would you do? I guess you'd take 6 over here and you get 3. Okay? So I'm going to do both of those just for the sake of board space. And I'm going to combine like terms. Okay? So this is what you